Welcome. Today, question number 28. Previous classes we considered when some part of the areas are removed or cut out. Today I will give some simple application. Some of the examples given today is required for practical purpose also. But these small, actually such small questions, not a big one. Sometimes what happens is, too big, people are very careful. Too small, some mistake, critical mistake they will make. So correctly understand. Locate centroid, all dimensions in millimeters. See here, this is a lamina. This radius is 80, this radius is 110. Okay, now, therefore, that means what? See here, one semicircle goes of radius 80, this is empty portion, one semicircle of radius 110. Now, make a note. Therefore, by chance, if you want this offset and this offset, it will be, this is 110 radius, see, this radius is 110, this is 80, this will become 30, this will become 30. Make a note. Okay, 1 minute. Or, in the question, they may not give this 110, see, they can give you 30 here and 30 here. Then, this is 80 fixed. See, when you come down here, see, this base is 80 plus 80 is 160. This full base is 80 plus 80, 160 plus 30 plus 30. 160 plus 30 is, how much it becomes? 82 into 30, 60. 80 plus 160 plus 60, 220. Sometimes it happens. 220 means this full will become 220, or this radius will become 110. Both are same. So anyway it can be given. And this total depth is given, how much? 500. Class, 3 parts. One rectangle, see. Actually what you have to do is, one rectangle, see here. I will do one thing now. I will take A point here, B point here, C point here, D point here. Rectangle is ABCD. Later remove it, ABCD. Full ABCD is one rectangle. Then this semicircle is there. And this semicircle is cut out. So one rectangle and two semicircle. Among the two semicircle, the bottom semicircle is cut out. Remember, make a note, cut out or removed. Okay. Now, I will remove that ABCD. This is only to understand. 30, 30 not given. Okay, now, so one, I will divide into parts now. See, I will take this semicircle as 1, this full rectangle as 2, the bottom semicircle, I will take 3, which is removed part. See, I already told you to understand correctly. See, I made dark here, warning. Note, 3 is cut out or removed. Also, observe one more thing. This is axis of symmetry. See here, how arrangement is this side, same this side. So this is your axis of symmetry. Therefore, if this is 110, 110, both are 110, 110. So x bar cut, not x, it's not x actually. You write, if I put this way means x bar not required. Not required. Only y bar required. Okay, start. Draw a neat sketch. See, this semicircle, radius 80, so diameter 160. This rectangle is 220 base, height is 500. This semicircle, radius 110, so diameter 220. Now, G1, that is centroid of this semicircle. If you want 2d by 3 pi. G2 for rectangle, everybody knows. G3, centroid of this semicircle, that is 2d by 3 pi. 2d, this is 2 times of 160 by 3 pi. This is 2 times of 220 by 3 pi. I wrote 2d by 3 pi, that's all. Now, you need only y bar. This time, your OX, OY not required. Since you want only y bar, you make a note here. I will dictate here. You should write. Let us consider reference line AB through bottom edge to get y bar. You write that note. See what I dictate, you should write. Let us consider reference line or reference axis AB through bottom edge. From there we will find y, we will take to upper side. Okay, start. Y bar direct formula. This time table all not required. See, formula is A1y1 A2y2 minus A3y3 by area equal to A1 plus A2 minus A3. Okay, start. A1 pi by 8 of 160 square into y1. Its centroid from base 500 plus 2d by 3 pi. I should not explain more. Plus second area 220 by 500. Its centroid from here is 500 by 2 minus pi by 8 of 220 square into this distance 2 times this diameter by 3 pi divided by pi by 8 of 160 square is first area, 220 by 500 is the middle area, second rectangle area, minus pi by 8 of 220 square, you will get 316.4935 millimeter. Over. Question is over. Now do one thing. Those who, question over now, I will locate centroid. Okay. Those who want, you solve the question. Only those who want, see, 1 minute, first of all, I will present the answer. I will first present the answer, then go for it. So that now onwards, I won't waste time for every class. Which one? Okay, see, I can use the same diagram. Why waste space? Okay, right here, last answer. Therefore, see, now when you write the final answer, you don't write all these things. You show only total height somewhere. Total height you mark. Total height is, how much it is? 500 plus 80, 580. 580. This total base width is 220. One more sketch you write. There you write. Therefore, centroid G for the given lamina will be as shown below. All dimensions in millimeter. From base you got y bar 316.4935. From here to center of rectangle is 500 by 250. So it will go slightly upper side. See here. There's a reason for it because see for this rectangle centroid is at center 250. Because of this cutout, centroid will further shift away. Centroid always shift that side where area is more. This is a remote area, and because of that area, again it will shift further. So centroid is here. This is your centroidal position. See, this is your y bar. Y bar equal to 316 point. I think I written higher accuracy. Okay, wait. Let the 580 go that side, disturbing me. This is 580. 316 point. I should write y bar. Okay, because your reference line AB is here. See, your reference line AB you have taken here. From AB you have taken y like this. Therefore, it will be y bar equal to 316.4935. Okay, now if you want from top, this distance will be from 580 subtract it. From 580 subtract 580 minus 316.4935. 263.5065 is the answer. Okay. And other, this is a symmetry axis here. See, directly mark the axis of symmetry, not required. Each distance will be how much? 220 means 110 and 110. This is the centroid for given lamina. Write the answer. Okay, now, those who are interested, do one thing. Take reference line here, top edge. Take y this way. Okay, I will tell fast answer. A1, A2, A3 will remain same. Your y1 will be, see, 80 minus 2d by 3 pi. Your y2 will be 80 plus 500 by 2. Your y3 will be 580 minus 2d by 3 pi. Calculate. A1 y1 plus A2 y2 minus A3 y3 divided by A1 minus A2 minus A3. Y bar will come 263.5065. I am seeing there only. Do you think I am calculating? It will come 263.5065. Then tell yes. See, you should tell them. See, that feeling should come. Yes, I got the answer. Those who want, do it. Okay, now this over. Now I will do one thing now. I will give you few exercises now. You should solve. But I will explain briefly. Briefly, I will explain. Very briefly. Okay, one. Calculator required for me. Here. Right, all colors are getting mixed up. Okay. See, I will give a rectangle for you now. This is exercise for you. Question number 29. You should work out. Exercise. Spelling no problem. What I'll do here is, I'll give something like this. This way I'll cut out. Here I'll cut out a little more. This way. This is the given lamina. This is the given lamina. You should work out. Some dimensions required here. I'll give this width first. See, this is not there. It is only imagination. This is a given lamina. Question is, locate centroid for the given lamina. 100. Okay, 1 minute. Centroid will come which side? That side. Okay. This is some 100. Where 100 should I show? I should show where 100. Okay. I'll give one radius for you. 70. That is a radius 70. And here I'll give to offset. 100 I require. 100 means 70 plus total 100 means 15, 15. 15, 15. Total depth is 300. That's all. All dimensions are in millimeter. Okay. Now, see how to find. First of all, make a note. Now, divide into, see, I will take ABCD here. ABCD, just to understand. Divide into 3 parts. 3 parts. Where part 1 is rectangle. Full, you don't think. You take part 1 rectangle. Anyone you can take it. Part 1 you take rectangle. That is, rectangle is full rectangle ABCD. This full ABCD is a rectangle. Okay, then part 2 and part 3 are cut out. Cut out. One upper side, one lower side. I will show part 2 and part 3. That means you are giving, see, now write one more sketch. Small sketch here, then I will remove it. Okay. One rectangle, then one part cut out here, one part cut out here. Okay, this way. This is rectangle, part 1 you make. This cutout you make part 2. This cutout you make part 3. Any one you can take 1, 2, 3. Now, for this, okay, leave it now. Now, draw a neat sketch. 15, 15, 30 plus 30 is 100. See, this full width is 100. Why 100 I cannot tell. Why it is 100 I cannot answer the question because, see, 70 plus 15 plus 15 is 100. So there, here, this is 300. Full is 300. And this base is 100, I write here. The base is 100, I write here to understand correctly. 100 base. So that base also becomes a diameter for this cutout. So for this one, your dia is 100. And here, one semicircle cut, 70. For this one, your dia is 70. Okay, now take this as figure number 1. Its centroid is here, G1. This centroid, well, anyone you can take 2. Okay, do one thing. Take this as 2. Anyone, whatever you want, 2. Its centroid is here, G2. This centroid is here, G3, figure number 3. And remember now, figure number 2 is cut out, 3 is cut out. So, all over. Now, one more thing there. I forgot one thing. One thing I forgot to tell. See, once again, see here. Write one more note. This is axis of symmetry. Oh, no, not there. You should write it here only. In the original sketch only write here. See, you put the sketch once again and write here. This is axis of symmetry. Axis of symmetry. Therefore, this full is 100 means, see, this and this both will be out of scale. 70 plus 15. 70. Oh, it is not 100. It is not 100 because 70 is the radius. If 70 is the radius, it becomes how much? Oh, by mistake, I took a wrong value there. I should take this radius. Okay, I'll do one thing now. Who will take the time? I'll take the radius as 15. 100 means 35. Okay, take 35. Okay, now taken care. Otherwise, what happens is, once again, I have to solve. Change the question. You take this as 35 and that's all. Okay, what to do? I first thought I'm giving it diameter only 70. Actually, I marked radius 70. No, you take this 35. Change the question. This is 35. So 35 means 35 plus 35 is 70. 70 plus 15 plus 15 is 100. Okay, now change it. So this diameter is 100. That diameter is 70. Okay, wow, sometime it happens. Oversight. So if this is 35 plus 15, this is 50, 50. So no need of calculating. Therefore, what happens now? X bar is not required, only Y bar required. Find Y bar from anywhere you want. Okay, find here. Find Y bar from here. Take reference axis AB, take Y this way, and find Y bar. I will not explain now. I will not explain. But I will write the expression for Y bar. But you should do one thing. You should not copy from me. See, this I will remove now. Okay, no problem. You should not copy from here. You should solve independently, then check the answer. See, I write Y bar formula. Y bar equal to Y bar from where? I don't have to write each and every class. Y bar from AB, how? Upward direction, equal to, be careful, A1 Y1 minus A2 Y2 minus A3 Y3 divided by total area. Total area is A1 minus A2 minus A3. A1 minus A2 minus A3 equal to A1 full rectangle area 100 into 300 A1 into Y1 with centroid from here 300 by 2 into 300 by 2 minus second semicircle pi by 8 of 70 square into distance of its centroid from here is 300. First of all, I am wasting time explaining. 300 minus 2 times of diameter 70 divided by 3 pi, again minus pi by 8 of 100 square is one more area into its centroid from here is 2 times 100 divided by 3 times pi divided by 100 into 300 is the full rectangle minus pi by 8 of 70 square, again minus pi by 8 of 100 square. You calculate the y bar. Now I have to calculate it. $100 into 300 into 150 minus pi by 8 of 70 square into 300 minus 2 into 70 divided by 3 divided by shift pi equal to so much minus pi by 8 of 100 square into bracket 2 into 100 divided by 3 divided by shift pi equal to divided by 100 into 300 minus pi by 8 of 70 square, again minus pi by 8 of 100 square equal to 160.173 millimeter. 1 minute. Correct. Centroid, see, if these cutouts are not there, centroid will be exactly at 150, center of rectangle. That cutout is lesser, this cutout is more. We are losing more area here, so centroid will shift slightly upper side. What is the answer? Forgot. 160.173. It is. Oh, red color is not there. 160.173 millimeter. Over. Now do one thing. Go for presentation. Last answer. Therefore, for the given lamina, right? Therefore, for the given lamina, centroid G will be as shown below. Okay, I'll show here. Small figure. Out of scale. Okay, done. Total depth is 300. This is axis of symmetry. Each will be how much? 50, 50, 50, 50. And from bottom edge, see, from bottom edge, you took y this way and your y bar came how much? 160, slightly above centroid. See, little more. Okay. This is y bar is 160.173 millimeter. From top, it will be subtract from 300. Minus 300. 139.827. 139.827. 827. Or do one thing. Find y bar from top edge. From top edge. It will be 100 into 300 into 300 by 2, A1, Y1, minus pi by 8 of 70 square into this 2d by 3 pi, minus pi by 8 of this 100 square into 300 minus this 2d by 3 pi. Calculate my guarantee. 139.827 millimeter. Okay, now I give one more interesting question for you. Actually, some will tell question 28 over 29 over question 30. Actually, it should not be considered as a question. Should not be considered as a question. Still, let it be there. Someone will be laughing by seeing this question. See, locate centroid. Locate centroid. It should look like something. This is 400. We are all dimensions in millimeter. Not little bigger. Okay. This is 400. This width is 150. Not 150. It is 125. Okay. 125. Over. This is semicircle, center here. Semicircle, center here. This is the lamina. It is same as this question, but do not solve. You write the question and directly give the answer, because see, this is axis of symmetry. This is axis of symmetry. You first write the question. This one, first you write the question. Then you write. And also, see, this is another axis of symmetry. Oh, this is also axis of symmetry. Therefore, what calculation? These two are 62.5, 62.5. These two are 200, 200. 200, 200. Okay, do it. This is centroid G. Over. Now, or you can do one thing. How the last time question solved, where one diameter is 70, other diameter is 100. Here both diameters are 125, 125. You solve the question in the same way. Find y bar. See what happens. Either from bottom or from top. Wherever you find y bar, it will 100% come 200 only. My guarantee. Okay. Now, I'll give one more exercise for you. 30 over now. 31. This is you have to solve. You should solve. Okay, solve one question. See. Question I'll give here now. This all you have to solve. Color problem. 50. Space sufficient. Okay, sufficient. 80. 50. Little more than 50. Okay, 80. This is the lamina given. Okay. This is the lamina. Then hints are given here for you. See, hints are given. This radius is 50 and one nimisha. I told 50 here, so radius will be 25. This radius is 25 and this radius is 40. This radius also is 40. Over. This is a question. That's all given. Okay. Now, how to solve? Very simple question. First, write the question. Once you write the question, make a note. This I will remove now. Make a note. First you write the question. Once you write the question, then dividing into parts. See, here there is no remote. See, light line here, light line here, light line here. One rectangle, either side two semicircle, upper side one more semicircle. So it will be total 1, 2, 3, 3 parts. How? See, what is the base? This is 25. If that is 25, the base will become 50. I should not explain once again. See, if this is 25, this base will become 50. 50. If this is 40, this will become 80. So 50 by 80 is a rectangle. 50, 80, little bigger. 50, okay, oh done, sufficient. How much accuracy required? One rectangle here. Then here, one semicircle. Okay. Now this diameter, this dia is 50. This dia is 80. This dia is also 80. Now, your choice, how you take it. Take figure number 1, figure number 2, figure number 3, figure number 4. Oh, forgot one thing. One thing forgotten. See, I don't know why I am forgetting it. Make a note. Again forgotten. See, axis of symmetry. So this distance and this distances are equal. Right here, equal. How much you will put later? Both are equal. Actually, how I equal? Both equal to, see here. This is 25. This is 40. 40 plus 25 is 65, 65. Equal. Both are 65 and 65. Therefore, X bar is not required. You require only Y bar. Okay, now once you make the note here, you take reference axis here. AB. Take Y this way. Now see. Dimension. This rectangle base is, see, 25 plus 25 is 50. First of all, high school level mathematics, 50. This full height of the rectangle is 80. Why? 40 plus 40 is 80. And this extra diameter radius here is, that is 25. 25. So the overall depth, if you want, is 105. 1 meter. I should check the camera first. Sometimes what happens is, I go too much to the right side, it may go out of camera. Okay, no problem. Correct. Okay, now, over. This much over. Now, this time, this is exercise for you. I am not calculating. Okay, see, I will remove everything now. Everything I remove. Now you should solve. If you cannot solve now, what I can do? Start. Y bar, red color. Y bar from AB. Take upward direction. Equal to, this time no negative, A1 Y1 plus A2 Y2 plus A3 Y3 plus A4 Y4 divided by total area. Total area is A1 plus A2 plus A3 plus A4. Calculate y bar from base up. This is for you in millimeter. Okay. I will slowly read the steps for you to understand. See correctly what I am telling. A1 50 into 80. 50 into 80 is A1. Oh, sorry, I have not marked centroid here. Not required. See, centroid is here. This centroid is here. This centroid is here. This centroid is here. This is your G1. This is G2. This is G3. This is G4. Remember, this is 2D by 3 pi. This is midway. This way you don't require. This way you don't require. Start. A1, 50 by 80 into 80 by 2. A1, Y1. A2, pi by 8 of 80 square into 80 by 2. Once again. A3, same as A2, pi by 8 of 80 square into 80 by 2. A4, pi by 8 of 50 square into 80 plus 2 into 50 divided by 3 pi. Divided by this area plus this area plus this area plus this area, you calculate. One minute. Actually, I got a shortcut method. I should not tell. These two, I am replacing by a circle of diameter 80. You don't do it. You never do those things. Danger. I can do if I want. That's why I am getting fast answer now. You never do those things. Diameter 50. Lastly, area 50 by 80 and pi by 8 of 80 is pi by 4 of 80 square, and lastly pi by 4, pi by 8 of 50 square equal to 44.9645. How much? 44.9645. 44. Again, see, by that time I forgot once again. 44.9645. I don't need, I will verify it. 9645. I will see now. See, if this semicircle is not there, centroid will be exactly 40 because of extra slight shifted. Okay, correct. From top. Okay, now, therefore, do one thing. Go for final answer. For the given lamina, see, full width is how much? The full width right here. Therefore, centroid will be as shown below. Full is 105. From the base here, AB, we took y bar this way, your y this way, your y bar came 44.9645 means center is 40, slightly above center. Okay, here. This is your y bar right here. Space is there, I'll write here. Okay, I'll do one thing, that 105, I'll write here. That is disturbing me, that 105. 105, I'll write here. I can write this side without bothering about camera. Y bar 44.9645, or from top if you want, subtract 44.9645 from 105 minus 105, 60.0355. See, fell down. Oh, yes, still working. 60.0355, 60.0355, 60.0355, 60.0355, calculated value over. And other symmetry axis is here. See, and this distance from here to here or here to here will be 25 plus 40. 40 plus 25 is 65. 65, 65. This is centroid G for the lamina. Now, those who are serious over question can do one thing. Take y bar from top. Do it. Good for practice. Take this way. A1 50 by 80 into y1 25 plus 80 by 2. For 2 and 3, area you know it, y2. y2 is 25 plus 80 by 2, 25 plus 80 by 2. For figure number 4, 25 minus 2d by 3 pi. Y bar will come 60.0355 millimeter. Oh, correct. Same answer. See, not same, it is guaranteed. Solve the question. Now, 28, 29, 30, 30 was useless, 31. Some more questions are there. I will take in the next class. Like, see, already feeling little tired. See, sometime hollow, see, you heard of, this is called hollow circular section. Centroid will be here only, but sometime hollow semicircular section. Little tricky. Where is centroid? It will be somewhere here. Then, in pre-stressed concrete beams, what they do is, in case of post-tension members, to pass the ducts, they make a cutout here, either rectangle or sometimes circular. That hole will be made in the concrete beam. Because of that one, there is loss of area for the concrete, so centroid will shift. Moment of inertia also required. This all I will take in the next class. Maybe one question here, where double cut is there. Then one question where cut is only on one side. One exercise for you. One side solve both side cutout. Then I will solve one side cutout, maybe rectangle only. Then one more homework I will give you where top side cutout, only top side cutout. And one more I will give you 2 equal cutouts and symmetrical cutouts. Then centroid will be exactly center. Okay, all these questions are easy questions, but I told I am going to cover each and everything. Therefore, go through all the questions. Don't laugh about that question number 30. He told a question and did not solve. Directly by symmetry, centroid comes to exact midpoint, both depth-wise and width-wise. Anyway, question is a question. If you want to solve it by usual procedure, your y bar will come equal to half the mid height only. Okay, thank you. We'll meet in the next class.